Hello everyone. For this tutorial video, I would like to show how to find the surface area and volume of cones, either circular or elliptical, and explain their similarity to pyramids, just like prisms versus cylinders. A cone is a curved surface that somewhat resembles a triangle, as it has a flat base and tapers off at a tip point, called the apex, just like how pyramids work with normal polyhedrons. In fact, you can argue that a cone is simply a type of pyramid with a circular or elliptical cross-section, rather than a polygonal one. Just like a cylinder has a different surface area than a prism, you will run into the same problem when unfolding a cone, because the height is no longer made out of different triangles, but is instead made out of one big sector of a circle, which has a fan-like shape. However, it is not 100% the sector of a circle, because it has a missing part of a sector inside that. So the surface area would more accurately look like a macaroni noodle than a 100% sector. As a consequence of this, the length will be the length of the overall sector minus the missing portion. It would not simply be plugging in the length of the overall sector. We can also see that this overall sector is about a quarter of a circle. So we would do 1/4 times pi r squared of the overall sector minus 1/4 pi r squared of the missing part, where the difference in length would constitute the r part, at least for the bigger section. So the answer would be 1/4 pi times the result of L2 minus L1 all squared, and that would be the surface area of the height of the cone. So we would simply add that to the circle that constitutes the base to get the final answer for the overall surface area. You may recall me mentioning earlier in the video the fact that a cone can be seen as a pyramid with a circular or elliptical base, and we can use this to derive the volume of the cone, as we would use the same exact trick and therefore get the same exact general result as the volume of a pyramid, i.e., by adding increasingly thin layers of cylinders. We recall that the general result was base times height divided by 3. So the volume of a cone will be seen as pi r squared, the area of the base, times height divided by 3. And so, that is our final answer. Join me in the next tutorial video, where I explain sectors of cylinders and cones, in a similar manner to how I explain sectors of circles after proving a full circle, and how we can use sectors and segments of 3D shapes, as well as the shapes themselves, i.e. cylinders and cones, to figure out complex curved 3D shapes, just like we figured out complex curved 2D shapes using circles and ellipses and their sectors. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.